But Apple just dropped something that completely disrupts that model. Apple Container version 1.0.
Just think about the sheer volume of code moving through our pipelines today. As the source material points out, traditional continuous integration pulls thousands of unvetted third-party dependencies every single day. And doing that subjects modern workflows to the constant memory bloat and security liabilities of an aging shared kernel architecture. That operational risk? It's massive, and it's exactly what this new tool is built to fix.
But to really appreciate the fix, we have to talk about the shared kernel problem, the hidden dangers of the legacy setup we've all just kind of accepted.
It really begs the question, is the shared kernel container architecture obsolete? Legacy tools rely on a single massive background virtual machine. It constantly hoards your system memory, even when you aren't doing anything. And worse, it creates a massive single point of failure for your entire development environment.
Think of that legacy shared kernel model like a massive cargo ship carrying dozens of exposed shipping containers. If a malicious process escapes its namespace, it hits that shared kernel and instantly infects all the neighboring workloads. Apple's new micro VM model? It's more like a fleet of individual speedboats. Every single container command generates its own dedicated virtual machine. You get isolated compute and absolutely zero cross-contamination.
So what's actually powering Apple's micro VM architecture under the hood?
What's fascinating here is the native stack making this possible. Apple Container is a command line interface written entirely in Swift. It bypasses those heavy third-party hypervisors completely, hooking directly into macOS 26 Tahoe's proprietary virtualization framework. A background service called Container API Server orchestrates everything, while a minimalist Swift-based init system called Viminid sits inside each isolated guest to handle the heavy lifting.
Now, you might be thinking, spinning up a dedicated VM for every single command? That's going to be incredibly slow, right? Well, an Alpine Linux container boots in about 300 milliseconds. Because each micro VM uses an ultra-minimal Linux kernel stripped of unnecessary core utilities, the lifecycle is blindingly fast. It boots, executes the payload, and is destroyed the very second the process terminates.
And here's the best part. Because resources are only claimed during active execution, your idle memory consumption snaps instantly back to zero. No persistent background app hoarding your RAM. No battery drain while you're grabbing coffee. The hardware is immediately returned to the host operating system.
Plus, this architecture isn't just a clever software trick. It's fundamentally built for Apple Silicon.
For any developer transitioning to Apple Silicon, maintaining compatibility with x86 production software has been a real headache. This engine solves that by natively mounting the macOS Rosetta 2 translation layer directly into the guest Linux file system. You can pull and test legacy Intel images totally transparently. No external translation bridges or clunky emulation layers to configure.
Apple also expanded this from a simple, short-lived task runner into a fully persistent environment with a WWDC 26 feature called Container Machines. By executing initialization programs like systemd, you can now run complex, long-running background services. Your macOS home directory is instantly bidirectionally mirrored into the isolated Linux file system. No slow emulated network mounts. It just feels like a native subsystem right alongside your Mac environment.
This level of strict isolation perfectly positions Apple Container for one of the most urgent challenges in modern engineering: securing AI code sandboxes. Think about it. If a hallucinated or adversarial AI model writes an aggressive script, running that agent on a shared kernel gives it a clear path to traverse your directories and potentially compromise the entire host machine. Recent security studies looking at engine-level isolation classes have proven that true containment requires robust engine-level boundaries if you want to safely execute untrusted AI-generated Python scripts. Comparing these engine classes really builds a compelling case for micro-VMs. Standard OCI containers share the host kernel verbatim, which leaves them highly vulnerable to namespace escapes. But Albo Container's micro-VM architecture relies on true hardware-level isolation with a distinct, highly optimized kernel. This physically traps malicious commands. Even if a rogue process breaks out of its immediate namespace, it's stuck inside a disposable virtual machine, not your actual Mac hardware. The crucial takeaway here is that this functions as a defense-in-depth quarantine zone. It is engineered precisely to contain untrusted autonomous operations. That strict hardware boundary ensures rogue AI scripts absolutely cannot traverse host directories, access your root credentials, or hijack your overarching network identity.
With all these architectural advantages, you're probably wondering how Apple Containers stacks up against Docker, and what it actually takes to migrate your workflow.
The good news? The friction of adopting the new CLI is practically non-existent. Apple Container consumes and produces standard OCI-compatible images. And the commands are nearly a one-to-one match. Pulling, running, and building images uses the exact same syntax you're already used to. You literally just swap the word Docker for container.
We do need to be totally objective about the current limitations, though. Apple Container is a hyper-specialized engine. Yes, it gives you incredible VM per container isolation, but it currently lacks multi-service orchestration. There is no equivalent to Docker Compose yet. If your local dev setup requires spinning up an app server, database, and cache all talking to each other in a single automated command, Docker Desktop's rich cross-platform ecosystem is still required. Apple Container is amazing, but it's not a universal drop-in replacement quite yet.
Which brings us to the ultimate verdict for developers, and exactly where this technology fits into the modern engineering stack.
Apple Container establishes a strict new baseline for macOS execution. It's the ultimate tool for infrastructure teams demanding clean CI/CD build contexts in seconds. It provides the perfect quarantine zone for security-conscious engineers testing experimental AI code, and it completely eliminates the background memory hoarding that has plagued developers for years. It fundamentally changes the risk model of local development.
So I'll leave you with this to think about. With the shared kernel paradigm effectively fractured by this release, you have to ask yourself, is your current local virtualization stack exposing your host machine to unnecessary operational risk? It might just be time to rethink how you run containers on your Mac. Thanks for joining me for this explainer, and I'll catch you next time.